Hi there, we're going to take a look at solving exponential equations using logarithms. So I have an example of an exponential equation on my board here. You'll note one thing is that the bases 6 and 4 are not powers of the same number. So if they are powers of the same number, like if I had 9x plus 1 equals 27, 2x minus 3, then the way I would start is to rewrite each of those as powers of 3. And then we don't need to use logarithms. Okay, so that's not what we're talking about this time. So we'll just get rid of that. So there's two methods to approach for this particular problem, and I'm going to briefly show you both of them. The first method, and this method is often better if you're working with calculators that only like to work with common logs or natural logs, and that is to take the logarithm of both sides of the equation. So I'm going to start by saying log of 6 to the x plus 1 equals log of 4 to the 2x minus 1. And then I'm going to use the power rule, the log power rule, to bring the exponents, the x plus 1 and the 2x minus 1, out in front. And so when you do this, though, make sure you are putting parentheses around that exponent, because it's the entire x plus 1 that's being multiplied by the log of 6 and the entire 2x minus 1 that's being multiplied by the log of 4. And now we just have log of 6 and log of 4 are just numbers. But we're going to leave them as those expressions for the moment, but we're going to treat them as if they're numbers. So the first step now is I basically have two parentheses multiplied by numbers, so I'm going to distribute. So I get x log 6 plus 1 times log 6 equals, and then distribute on the other side, 2x log 4 minus 1 times log 4. And so then I'll collect the x terms on one side and everything else on the other. So I get x log 6 minus 2x log 4 equals negative log 6 minus log 4. And now we have all the x's on the left, so we're going to factor those. So we have x times log 6 minus 2 log 4 equals negative log 6 minus log 4. And then last but not least, we will divide both sides by the log 6 minus 2 log 4, and I get x equals negative log 6 minus log 4 over log 6 minus 2 log 4. Now, personally, I don't think this is the best way to leave the answer. I would multiply the top and bottom by negative 1, so x equals log 6 plus log 4 over 2 log 4 minus log 6. And so if I want an exact answer, generally speaking, we will accept this, although this actually can be reduced to a single logarithm. And if you're interested in that, we can talk about what that would look like, but I'm not going to go into it at the moment. But if we want the approximate answer, then we're going to plug this into our calculator. So I'm not going to be able to show that on here, but I'm going to quickly take out my calculator and go ahead and type in, and they're all base 10, so it's just log of 6 plus log 4 over 2 log 4 minus log 6. And I hit enter, and I get that this is approximately 3.24. So if I want an exact answer, this is sufficient, although like I said, we can write it as a single. If I want an approximation, I would do it this way. Okay, so that's taking the log of both sides. Now what if we want to use, the other way we can do this is we can take the definition of a log. And so what I can do is I can say, well, which one of these do I want to have the base of a log? It doesn't really matter. So I'm going to let 6 be the base of my new logarithm. So I now have log base 6 of 4 to the 2x minus 1 equals x plus 1. So this is just using the definition of a log, where we have b to the x equals y, can be written as log base b of y equals x. So that's all I'm doing there. Next step is the same type of thing. I'm going to put 2x plus, or minus 1 rather, using log of a power, 2x minus 1 out in front, log base 6 of 4 equals x plus 1. You'll notice with this method, we don't need to work with two log two or more logs on either side. We've just got the log on the one side, but I'm still going to distribute. So 2x log 6, log base 6 of 4 minus 1 times log base 6 of 4 equals x plus 1. Just like the previous problem, or the other method, I'm going to collect the x's on one side and everything else on the other. So I get 2x log base 6 of 4 minus x equals log base 6 of 4 plus 1. And keeping in mind that this is separate from this and this is separate from that. So I would usually put this out in front just so it's not confusing. And I'll do the same thing here, and then I'll factor. Actually, in the second one, I'm not going to do that because I want to, the minuses makes it a little bit different. So I'll do x 2 log 4, sorry, 2 log base 6 of 4 minus 1 equals 1 plus log base 6 of 4. And then I'll divide both sides again, and I get x equals 1 plus log base 6 of 4 over 2 log base 6 of 4 minus 1. And if you're doing it this way, then this is my exact answer. It might not take much for you to see that these are essentially the same answer. I'd let you kind of play around with what that would look like. But using change of base, we can easily turn that into the same equation. And so the other thing is, again, let's just check to make sure. I'm going to use my calculator to plug this in. So I have 1 plus, and now I have to use get to my logarithm tool. So log base 6 of 4 over 2 log base 6 of 4 minus 1. And lo and behold, I get the exact same answer. Okay, so these are the two methods that we can use for solving exponential equations. So this one is using the definition of a log, and the other one is using the logarithmic property of equality because we're taking the log of both sides.